So this is the 2019 foundation paper. It's the last set of papers that we actually have access to before COVID. I know it seems ages ago because we're now in 2022, but this is the last set of proper papers we have. Blank page. So, nice easy question to get us started. This is a diagram of metals. All metals look like this. They are positive ions in a sea of delocalized electrons. Okay. Solid is a silver because the ions are tightly packed. Metal is a good conductor of electricity because the electrons are delocalized and free to move. Silver metal, dense when hammered because it is malleable. So you had to use these words here to get the answers. Nano-sized particles are 1 to 100 nanometers. They have different properties than bulk. They are antibacterial, antiviral, and antifungal. Okay, so they're the properties of silver. So looking at this, correct the 3 mistakes. They were circled for you. It didn't matter what order you put them in, okay? So this one here is orange, pH 4, that's an acid, okay? This one here, water, green, that should be 7. This one then was the toughest of the 3. They circled that. If you went on your table of ions and looked at it, okay, sodium would be positive, carbonate's 2 minus, so it would be Na1CO3 2. Na2CO3 minus, and you can drop it down and you would have got that, okay? There is another error. Up here, sulfuric acid would not have turned green. It should have turned red. Then it says, using the chemicals in the box, complete the table, which is a bit of a weird layout there, okay? So carbonate, what gas are we thinking about? Carbon dioxide, okay? And then barium chloride is used to test for sulfate. That's one of the ones you need to know. Describe the test that you use to identify the gas produced, okay? So it's carbon dioxide is produced. What do we use to test for it? Lime water should turn cloudy. You could have written bubble through lime water. Bubble through lime water. Nice little graph. Give the letter of the metal that did not react. You can see that C has stayed constant, no temperature rise. So that's the one that did not react. Maximum temperature rise, do not lose an easy mark. It starts at 20, not at 0. Goes up to 53, so take them away from each other, you would have got 33. State the term used to describe a reaction that gives out heat, exothermic. Completing this then, and I've done it wrong, magnesium sulfate. Sorry about that, because it's sulfuric acid. Give the test used to identify hydrogen gas, including the expected observation, lit, splint, squeaky pop. Can you see how we've gone halfway through this paper and there are 4 or 5 different questions in terms of identifying chemicals from last year, okay? Turn to your table of ions for this. Okay, turn to your table of ions, top, swap, drop. Top, swap, drop, okay? When completing these activities. Again, this is the second time this question's come up in terms of looking at covalent bonding. This is near enough exactly the same question that was on the SAMs, okay? Look at the structure of it. Carbon's got 4 in its outer shell. How many does it need to have a full outer shell? Well, it needs 8 in total, so 8 take away 4. It needs 4 more. How many hydrogens can you put around it? You're going to put 4 hydrogens around it. Okay, to make it, everything's got full outer shell. They're both non-metals, so it's covalent bonding, okay? And then it says circle what it is, covalent, okay? Not giant structures. Giant covalent would be this structure over and over again. So another carbon by here, another carbon by here, you know, over and over again would be giant. That's very simple because it's very small bonding happening there. Okay. Kind of a flow diagram of what we've got to work out, okay? So that is a high melting point, so just follow it through. Oh, sorry, the first question. Does the substance conduct electricity when solid? No, so we follow it down. It's got a high melting point, high. Does it conduct electricity when molten or dissolved? Yes, it's giant ionic. Follow it down, okay? That's a very low one, okay? And it tells you it does not conduct electricity, okay? So no, low, simple molecular. This is quite a high one again if you needed it. Does not conduct electricity. High, no. So it helps you work it out. Methane is a simple molecular. Methane is simple molecular, simple covalent. very small structure. Methane's that, CH4, okay? Things that are giant covalent are going to have upwards of 60 to 100 carbons in them, okay? Same with giant ionic. It's going to be over and over and over again, okay? Things that are simple or small are just going to have mostly under 10 molecules within them. Again, this is a question from last year, so you have to use the table to work out the MR, okay? And then it says calculate the percentage of hydrogen, so do the total of hydrogen divided by the total MR times by 100, because again, it's a percentage, and you should have got that. Okay, tough question here, a lot of reading and looking at what's going on, okay? Circle the number of alloys that contain an element from group 4, okay? So you had to go find group 4 and work out which ones contain, and you can see here that I've put ticks next to the ones that contain a group 4 element, okay? Circle percentage range from mass of copper, so you just had to work it out looking at if you had 75 plus 6, that would have given you 19, but 75 plus 24 would have given you 1, so that's the range there. Again, reading through it, these questions are designed to catch you out. The alloys contain at least 3 metals. They all do, okay? All of the alloys in that situation contain at least 3 metals. Not all alloys do, okay, but just in this situation. Okay, this was a tough question. All of the alloys containing silver are used for decorative purposes, okay? You've got to be careful of the wording of the situation, okay? A soldier had an electrical circuit containing 0.00011 kilograms of silver, okay? So it was 90% tin, 5% silver, okay? So 5% silver was that, okay? How do I get to 1%? Okay, so I did a little ratio here. So I worked out what 1% would be, and then obviously I times that by 90 to get the percentage of tin, okay? That's a tough question. 2 marks, okay? Show all your working, show what your thought process is. Then looking at metals extracted from ore, okay? Total number of atoms in cryolite, okay? So you've got 3, 1, 6, okay? Be really careful, okay? You've got 3 sodiums, 1 aluminium, 6 fluorines, okay? Name the metal ore that is in a 1:4 ratio of metals, okay? So I went along. That's in a 1:2 ratio. That's in there's 2 metals there, 2 non-metals, so a 2:2 or a 1:1. This then is in a 4 because you've got sodium and aluminium, and then 6, so that's technically, if you broke it down, a 2:3. This one then is in a 1 because there's 1 metal to 4 non-metals. This one then again is a 2:2 or a 1:1, and this one is a 4:4 or a 1:1. So you have to spend a little bit of time to get that 1 mark, okay? And it would have been saltpeter, okay? Give a reason why lead chloride needs to be melted for electrolysis. They need to be melted or dissolved, okay? The reason for that is that ions need to be free to move. Not electrons, it's ions, okay? Explain why chloride ions move towards the positive electrode. Cl, and again, want to see panic written somewhere just to help you, okay? Positive electrode is the anode. Positive, chloride is negative, moves towards the anode because opposites attract, okay? State what's meant by reduction in this equation, okay? Right oil rig, think about it. Oxidation is loss of electrons, reduction is gain of electrons, okay? Reduction is the gain of electrons, it's gaining 2 electrons to go from an ion to an atom. Tough question here, okay? We would have written it like this. Minus 2E gives you Cl2. And then just move it around so you can get the way they've written it in the exam. They just use that then to catch you out. Okay, so tough. But look for it. We know that it's not going to be that. Okay. We know that it's diatomic. Okay. We know that chlorine's diatomic. So you actually just had that one and that one to use in terms of diatomic because chlorine is diatomic. Naturally exists in a pair. Okay. And then that one is balanced because you've got 2 chlorines, 2 chlorines. Last question. We've practiced this quite a lot. Nice question, okay, for 6 marks. Use the information in the diagram to explain why it would be a suitable location for aluminium works, okay? Close to the docks for import, to import the resources you need. Close to a railway and motorway for export, so when you've made the aluminium, you can export it. Close to a housing area for workers, but not too close, so you won't have air or noise pollution. And then close to power stations, its extraction requires electricity. Okay, that would have likely gotten you 6 marks. You might need to expand it a little bit, but that is a really nice 6 marker with not a lot of information required. Information in the table to describe how the burning of the fractions depends upon the size. So the larger the molecule, the more difficult it is to burn. Okay, it's more smoky when it burns. Okay, next question then, which is quite unusual for a higher paper, is to draw a bar graph. Okay, a bar graph of information. Then you had to draw a trend line to work out where you believed that the carbon 7 would be, okay? So a bit of a different one, quite a difficult scale as well, because there's 50 there, so each of them was 5, okay? And it was minuses, very difficult scale, very difficult question, okay, in terms of bars, because they don't often come up. Then it says, one method that would safely put out a bit of spilled petrol, okay? So think about what you know about petrol. What part of the fire triangle would you use? Remember the fire triangle, you've got heat, fuel, oxygen. Okay, it's obviously a petrol fire. You can't put stuff like water on it. So fire blanket, because it's a small petrol fire, removes the oxygen. So the reason is, what is it doing? It's removing the oxygen. Okay, complete combustion, when anything completely combusts, you get CO2 and water. Okay, so that would have been 1 mark. Then it was the balancing, bit of easy bit there because carbon was 5, so you had to put 5 there to get carbons. Okay, and then the hard bit then was working out, well, you've got 12 there, so you've got working out how many hydrogens and oxygens you needed. Okay, explain why hydrogen fuel cells in cars are better for the environment. Okay, so I know there's a lot going on with hydrogen fuel cells and they're hard to store, hard to transport, but better for the environment. When you combust hydrogen or to make them, the only product is water. Okay, the only product is water because it's H2 plus O2 makes H2O plus energy, okay, and that energy then can be used to power cars. There's no carbon dioxide being produced, okay, so will not contribute to global warming. Okay, there are problems with hydrogen fuel cells. This is so difficult to store, okay, difficult to store. It's really volatile, but they're looking at environmental things with hydrogen. It's because the only thing that's produced is water. Okay, question then, burning fuel. Okay, so apart from measuring the mass of water, describe all measurements that are needed to be taken to calculate. Okay, you have to do the mass of the fuel before and after, the temperature of the water before and after. If you don't write before and after, you don't get the mark. Okay, things that need to be kept the same: distance of spirit burner from the bottom of the beaker. You could have done surface area of beaker. Okay, where you place the thermometer. So there were a couple of them. We have practiced them all in class. This is a big thing that people lose marks on here because they don't write before and after. Then it says, show which one it would have been. It was an exothermic reaction.